Hi everyone, let's begin two-way ANOVA. In my previous video, one-way ANOVA, I had already explained you, and now two-way ANOVA, how we have to perform with the use of Jamovi. So what we have to do, let me go there and open a file, and this file that is, we are going to browse it, and one-way ANOVA we have already done, two-way ANOVA, today we are going to perform. So two-way ANOVA file, it is opening. And this is my SPSS file. There are, we can see, this is the number one column. This is the student's name, educational background, right? And this one is the work experience and salary. So let me discuss for this case, what is actually this case. Uh, this is the case related to MBA aspirants. Those are interested in knowing the impact of educational background, whether they are arts and commerce graduate or they are science and engineering graduate, on the final placement salaries. So they are also aware that previous work experience has an impact on the salaries. So therefore, he chooses educational background and work experience as the two independent variable, and salary is our dependent variable. So based on the educational background, respondents are categorized into two groups. One belongs to the arts and commerce stream and another one is belongs to the science and engineering stream. So based on the previous work experience, respondents are again categorized into two groups. One is with experience and one is another group is without experience. So that would be a 2 by 2 table. 2 by 2 design. There are two independent variables and one dependent variable. So a sample of 30 students is randomly chosen and their salaries from campus recruitment as well as information on the educational background and work experience. So for educational background, we had denoted one that represents arts and commerce and two represents science and engineering stream. That is our nominal data. So for work experience, we have again assigned a number. One is for with experience and two represents students without experience. So salary is given in the multiples of lakhs, right? So there are three columns, four columns, I could say. 30 students data we have taken in the first column. In the second column, educational background. Educational background, you could understand, first represents arts and commerce, two represents science graduates. I think same thing we have done. One represents arts and commerce and two represents science and engineering stream. And work experience, one represents those students, those have work experience, and two represents those students, those do not have work experience. So this one is the salary, and salary we had already mentioned. Salary, it is in terms of the lakhs we have defined here. So 8.50 means 8 lakh 50,000, 10 lakh 80,000, 9 lakh 70,000. We are going to read like this. So here is, we will created hypothesis. Hypothesis here is first hypothesis, the educational background has no impact on the placement salaries of the MBA students. This is the first hypothesis. And alternate hypothesis, of course, can be students from science stream will get more salaries during the final placement. Second is the previous work experience has no impact on the placement salaries of the MBA students. And third one is that is the interaction effect. Interaction effect, when we are taking together the educational background and previous work experience, so will these two parameters will give impact on the placement salaries of MBA students. So these all three hypotheses we are going to check in Jamovi. And here is, this one is the interpretation. These results I have received through SPSS. You could able to see significance level, right? Which one is giving impact and which factors not giving impact. And finally, we had interpreted all those things. But we are going for interpretation part later on. First, we are going to running all this data in Jamovi. So now you can see this one is the student that could not be. So what we have to do, we will go there, right? That is the data, right? We can go there, setup, right? And there is the new variables, right? Variables, there would be, this one is the, we can do, this one is the salary. And a moment we will go back, this is the data, and this one is the students, and again we'll go to variables, then add it. And student, that is not a continuous data, that is simply a nominal data, right? So we had assigned this nominal data. Then further it is, we will go back, this one is the students, that is nominal. Now sign is changed. Educational background, that is again our nominal data. So we will go back. And this one is the, we are going to add it. Educational background, that is the, we can assign it, that is again a nominal data. So A and C, arts and commerce, that is representing 1. And SNE, science and engineering, that is assigned 2. So I'm sure that's correct. Further, we will go back. Work experience. Work experience, again, that is our nominal data, right? Further, we will go back to this. What is the work experience? That is not ordinal data. That is nominal data. Work experience. Those have work experience. We have assigned 1. Those do not have work experience. Work experience, they do not have, right? That we have assigned 2. So this one is, I'm sure it's clear how we can assign all these values. And salary, it is our own continuous, this is the continuous variable. I just want to show you. This one is the salary, and that is on the continuous scale because that is in terms of lakhs, the salary we had already measured. So now our data is ready for the analysis, and we had already assigned correct scales. Now further we will go to analysis, and here it is, you can see ANOVA. ANOVA, it is one way ANOVA we had already performed, and this is the 2 by 2 table, right? So there are one dependent variable and 2 independent variable. So this table is known as two-way ANOVA. So what we have to do, simply salary is our dependent variable because salary depends upon all these 2 parameters. One is educational background and another one is work experience. A moment we had transferred this educational background, right hand side you can see educational background, sum of squares 1.86, degree of freedom is 1, mean square 1.86, F ratio that is 0.377, and p value 0.544. It means we can say this particular p-value because it is greater than 0.05. So we can say educational background that is not giving impact on the salaries. It means there is no significant difference whatever is the students their past educational background, whether they are science graduates, science and engineering graduates, or they are commerce and arts graduate. Next, we come to the work experience. Will work experience giving impact on the MBA student salaries? So let me transfer this. So work experience, now you can say sum of square 65.835 and 65.835. This one is the, we can say mean square, degree of freedom is 1, F ratio is 23. And now you can say P value that is less than 0.05, and here it is 0.001. So yes, of course, we can say this one is the work experience giving impact on the final placement salaries. So in that way, you can check this, right? And this one is our interaction effect, right? This is our interaction effect. This is the components, and this one is our interaction effect. And interaction effect, you can see here, that is educational and work experience together, whether it is giving impact on the salaries. So this one is the p value that is 0.701. So we can say null hypothesis, we have failed to reject null hypothesis, and this interaction effect, right, it is not influencing, right, salaries, right, jointly. So what we have to do, let me copy this and we will go back, right, and where is we had put it all the values, let me paste it here, and we had pasted this one is, and let me cross check. This one is the educational background 0.626, right? This one is the 0.626, absolutely right. Work experience, let me check work experience, that is also same, right? Same. work experience also, right? That is less than, and interaction effect when we are talking about 0.701. I'm sure all the values are exactly same when it is doesn't matter when we are interpreting with the help of SPSS or we are interpreting with the help of not interpretation, we have to calculate it with the help of Jamovi. So here it is, SPSS is a paid software, but Jamovi is a free of cost. So it doesn't matter if you have SPSS software or you do not have SPSS software. It doesn't matter, and you have to analyze all your data with the help of. So we can validate this data with the help of Jamovi also. And here it is our interpretation. We can say F statistics corresponding to work experience is 23.896, which is significant. And F statistics for educational background is 0.243, which is insignificant because p value that is 0.626. And the interaction between work experience and educational background is also insignificant. So in our case study, only one factor that is significant, that is work experience. Rest of these previous educational background and interaction effect of both these together, that is insignificant. That's clearly mentioned. So therefore, null hypothesis is only partially supported, while the previous work experience has a significant impact on the placement salaries of MBA students. So their previous educational background does not. And how we are going to report these results? In the similar manner, you are going to report these results in your research article, or you are doing your dissertations, or you are doing your thesis. So PhD thesis. So this one is the previous work experience has a significant effect on the placement salaries of MBA student. So this one is 23.896. P value is corresponding P value is 0.00. However, previous educational background does not affect the final placement salary significantly. And here it is the p value, this is the 0.26. So the interaction of the previous work experience and educational background also does not affect the placement salaries significantly. So in the similar manner, we have to do. Now we come to the post hoc analysis. Why we are doing post hoc analysis? That's important. So let me post hoc test, right? This one is the post hoc test. And when we have to check, this one is the two case. And now we can see this one is the, we can perform educational background. Further, we have to shift towards the post hoc test, right? Post hoc test, it will actually do it. All these three parameters we have to transfer, and it is corresponding to each other that we have to check. So post hoc test, you can see this one is the last one table, and this is reflecting is what is happening here. Now there are, you can see A and C, educational background with work experience. Those are arts and commerce graduates, but they are, this one is the, those have work experience. So now you can see 0.005, and this one is the less than 0.05. And corresponding to this, when we are talking about educational background, science and engineering with work experience, so this is not significant. Now we can see 0.924, and science and engineering without work experience, right? So that is all, that is significant. And further we can cross check. This one is science and engineering, right, with work experience 0.0, that is also significant. And here it is science and engineering without work experience, that is not significant. And in similar manner, you can cross check all those things. And similar manner, you have to report all those results in your post hoc analysis also. Further, let me just paste it here. And now how we have to, because I would just want to give you meaning of this post hoc, why we are performing this post hoc. In a scientific study, post hoc analysis from Latin post hoc means after this. So consisting of statistical analysis that was specified after the data were seen. So they are usually used to uncover specific differences between three or more group means which an analysis of variance test is significant. So corresponding to each other, we are going to check. So I'm sure this test is clear, two-way ANOVA. I'm sure that would be helpful. And in your case studies or in your research data, you could be able to apply this post-hoc analysis, as well as you can apply this two-way ANOVA. So I'm sure this video would be helpful. Stay tuned and keep watching.